Alrighty, hello again. Because I'm a glutton for punishment, I'm going to give this a third try to see if I can actually provide you with a short tutorial for standard quiz question number 8, multiplying binomials. So just to give you an idea of how frustrating the past hour has been, you might be able to see all the multiplying of binomials that I've done the past hour without any successful recording of the video. So, here's trial number 3, and if it doesn't work, I'm just going to go read. So, first off, we're trying to multiply binomials. So when we taught this, or when I taught you this at the beginning of term 1, we used a couple different strategies, particularly 3, but I'm going to show you the 2 most common ones. So to do that, I've got to come up with an example. Thankfully, I have lots of examples here to work with. So let's go through and work on this one first. So, giving myself some space to do the other method with another problem in just a second. We're going to multiply the binomials 2x plus 3 and 5x minus 1. So I'm going to first use the most common strategy called the FOIL strategy. So the FOIL strategy is also called the double distributive property, or double distributive method, or the double sprinkler method. And basically FOIL is an acronym that tells us which terms to multiply together. So what we're going to do is I'm going to write out the problem again, then I'll illustrate the FOIL method. So first, the FOIL, the F in FOIL stands for first, so we're going to multiply the 2 first terms together. 2x times 5x. Well, 2 times 5 is 10, and x times x is x squared. So next, the O stands for the outer terms, so I'm going to multiply 2x and negative 1. That'll give me negative 2x. And then I stands for inner, so it'll be the inner terms. So positive 3 times 5x will be positive 15x. And then last is, well, L stands for last. So multiply the last terms in each binomial. Positive 3 times negative 1 is negative 3. And so there we go. We've multiplied the binomials. Now we're not done though, because we need to see if there are any that can be combined in order to simplify this completely. So what I need to check for is any opportunity to combine like terms. So it's important enough that I'm writing it down with an exclamation mark. So combining like terms means we need to identify if there are any that have the same family name. So when I look at this, I see that we have negative 2x and positive 15x. Those are both x's, so we're going to need to combine them. So I'm going to put a box around them just to kind of set them apart from the other two. And now I can actually do the combining. So negative 2 and positive 15 is going to be positive 13. And since they're both x's, that'll be positive 13x. The exponent doesn't change of the x, it just becomes x. And then for my rest of my answer, it's just going to come straight down. 10x squared and minus 3. So my final answer here is negative 10x squared plus 13x minus 3. Okay, next, so that is the first strategy, that is the FOIL strategy. You can see it's got kind of like the double rainbow or the double distributive property going on. Okay, my next one, I am going to use, as an example, we'll use 3x minus 4 times x minus 2. And so this strategy that I'm going to show this time will accomplish the same goal. It's called the box strategy. You also might have heard it called the area model. And as the name might suggest, the name box, we're going to use a box. So the first place to start when using the box method is to draw a box divided into 4 spots. Because what we're going to do is we're going to multiply out similar to this way and then fill each one with a term. So first I need to put the actual binomials around the outside. So 3x minus 4 and x minus 2. So there's everything kind of set up to go. And now I'm going to multiply into the box. So multiply into box. Okay, so up here it's going to be x times 3x. That's going to be 3x squared. Over here, x times negative 4. It's going to be negative 4x. Down here it'll be 3x times negative 2. negative 6x. And lastly, over here, it'll be negative 2 times negative 4. Well, a negative times a negative is a positive, and 4 times 2 is 8. So I've filled in the box now by multiplying into it. Okay, now what we ended up with is an expression like this. We can pull it out. So 3x squared minus 4x minus 6x plus 8. And now again, we need to see if there are any like terms. So in this case, just like in the first example, we have minus 4x minus 6x. So we have like terms with the x's. Negative 4 minus 6 going to be negative 10x. And then the rest comes down. So 3x squared, there's no other x squared terms. And plus 8, there's no other constants. No, they're just numbers by themselves. So our final answer is 3x squared minus 10x plus 8. Alrighty, welcome back. As it turns out, the last video worked, so crossing my fingers that it's going to work this time. I should be able to do a second example of both the FOIL method and the box method for multiplying binomials for standard number 8 on the standard quiz. So here we go. So first off, need an example. So let's see, when last we spoke, I did those two examples, so why not use one like this? So there we go, x plus 3 times 2x plus 3. I'm going to multiply these two binomials, and first I'm going to use the FOIL method. So, with a little less narration this time, I'm going to write it out again so that I can draw my double distributive lines, or my little curves, whatever you want to call them, the double sprinklers. And I'm going to first multiply x times 2x, which gives me 2x squared. Now we'll do the outer terms. So x times positive 3 is positive 3x. Here we've got positive 3 times 2x, it's going to be positive 6x. And then the last terms, positive 3 times positive 3 is positive 9. So now that I'm here, I would be done, except I need to combine like terms. So looking at my expressions here, and using a different colored pen just for kicks, got positive 3x, got positive 6x, and so those are definitely like terms. They're both x terms. Positive 3 plus positive 6 is going to be positive 9x, and then the rest comes down. 2x squared plus 9x plus 9 is my final answer. And there we go, FOIL method. FOIL method has the little curls, the little rainbows, whatever you want to call them. Okay, next, let's do one more. We'll use the box method this time. So I'll get one with a little more interesting pieces in it maybe. Go with x squared plus 1 times 3x plus 5. There's nothing wrong with having an x squared in there, it just means that we've got to be careful when we multiply it out to make sure we do everything correctly with the exponents. And again, on this side, I'm going to use the box method or the area model. So it starts with a box. So I divide it into 4 spaces, and then I write out my terms from the binomials around the edges. And again, notice that I'm keeping the signs with me. That makes sure that I don't make an integer mistake that I might have made otherwise. Okay, so here we go. We're going to multiply into the box. Multiply into the box. 3x times x squared is going to be 3x cubed. 3x times positive 1 is going to be positive 3x. Positive 5 times x squared is going to be positive 5x squared. And positive 5 times positive 1 is just going to be positive 5. So we filled in the box. Now we can kind of write out what we have. 3x cubed plus 3x plus 5x squared plus 5. And so now we'd need to combine like terms if there are any. But when I look at this, 3x squared, 3x, 5x squared, 5, none of these are actually like terms. They all have a different exponent. Again, they all have different exponents, 3x to the third, 3x, 5x squared, positive 5. So there are no like terms, so the only thing we could do to make sure this is most precise, most correct, is we could write it in descending order. So biggest exponents first. 3x cubed plus 5x squared plus 3x plus 5. So there is our final answer. And voila! After this video, you've seen 2 different strategies for actually multiplying out binomials as you need to do on standard quiz question number 8. Hopefully this has been informative, and thank you for tuning in. Have a good night.